As you can probably imagine, time is very important when it comes to computers. You want your computer to be in time, especially if you have more than one computer. Say you have 1,000 computers and you want to like do stuff across all of them. Well, they better be in time sync. And it's not really a problem that we have, but when I saw this product, the Tmebeat Timecard Mini, and the other one in here, this one, it's called the G0KK. I don't know if you're supposed to call it GOK. I probably should have asked them how to pronounce it, but it doesn't matter. It was just too cool to not check out. I've never played with one of these. This guy right here, the GOK one, and this one, as you could probably guess, is the Timecard Mini. You may or may not be aware, but basically every computer on the planet, I imagine phones have them, but definitely like your gaming computer on its motherboard will have something called a real-time clock. Usually the clocks on a computer are not super accurate. For example, the real-time clock in your average computer will drift multiple seconds per day. For example, this little add-on chip right here can hold time down to 0.03 seconds per year, which is very accurate. Let's focus on the Timecard Mini for now because the actual bones of these two products are pretty much the same. You've got a Raspberry Pi compute module 4. We've got a little spacer board on the back, but this is the important part. This is the time teller. Right here, you can see the U-Blox LEA M8F0. It's a GPS chip. So what this board basically does is connects to GPS, GLONASS, Galileo satellites, gets very accurate time data from them, and then outputs it through these pins to our little Raspberry Pi. And then we've got two little spots over here for add-on modules. These, you can put little chips on them. And this chip, the SIT5811, can hold 1 part per billion accuracy for up to 8 hours. In terms of the rest of I/O, it has USB here. It's got an SD card slot here. Bunch of dip switches, primarily used for setup. You've got your connection points for the Raspberry Pi, the full set of GPIO pins for the Raspberry Pi, which is super nice. An antenna connection, USB on the go connection, 2 Type-C USBs, and Ethernet. Now you would use this Ethernet to, well, provide internet to the Raspberry Pi and also to send your time signaling out. As you can imagine, it's a little weird to be plugging a computer into a computer, right? This is a PCIe card. Why would you plug this computer into your other computer? The function of this is literally just to give power. It's basically so you can add a very powerful, very accurate time server to your existing infrastructure without having to put like a whole new rack unit in or like duct tape it to the side of your rack or whatever. Aside from these just being cool, the reason I asked for them was to make a time server at Linus Media Group. For us, the thing that kind of sparked this idea is we were setting up a cluster of computers using Proxmox, and Proxmox requires that the time sync be within about 5 milliseconds. You can achieve that pretty easily by having any local time server. For instance, most routers will let you enable an NTP server that runs on them, which is what we did, and it worked totally fine. But you know, it's me. I want to do it like fancy or silly, and that's what we're gonna do with these. Do you think that this, I mean, it just needs to provide power, right? I run the Timecard Mini in the GOK 1 Mini. It's like time serverception. Okay, now I think I have to try that. I really hope this doesn't break it. I'd feel kind of bad if I broke it. Oh, look at that. They're both blinking. Look at that, wow, it works. Okay, we've got a time server in the time server. Can you see how this makes perfect sense now? It should be running already. You can see from the logs it's connecting to Cloudflare. That's an NTP server, a public time server that I configured just as like a secondary source. Usually you'd see a bunch of GPS logs, but that's because I haven't told you about today's sponsor.
Thanks to MSI for sponsoring this video. Unlike your homework, there's one thing you won't want to put off. MSI's amazing back-to-school deals. They're offering a wide selection of laptops, gaming PCs, GPUs, and more. Check out the MSI Cyborg 14, an entry-level gaming laptop that's sleek and powerful, perfect for gamers, students, or anyone who needs both. It's equipped with a 14-inch Full HD screen, an NVIDIA 4000 series GPU, and an Intel i7 processor. Not quite what you're looking for? No worries. MSI has plenty of other laptops on sale right now. Be a good student and check out MSI's back to school deals using the link in the description below.
Sorry, wrong thing. I mean, I haven't plugged in the antennas yet. So let's do that. You can use basically any GPS antenna as far as I'm aware. I got these ones on Amazon. This is meant for a boat, and I needed to get an adapter because this uses BNC connectors. Now I wonder, will we have GPS reception in here? 0 satellites in view. Look at that. 10 satellites in view. Ooh, wow, wow, wee woo. All right, look at this. We got our Gawk one. Oh, look, it's ripping, dude. Nothing like measuring your time in nanoseconds. It's a very in-depth config file. You can mess around with a lot of different settings and some far more advanced than others. But what we're most interested in is the primary clocks and secondary clocks. Primary clocks, usually you set as your most accurate source of time. In our case, we're gonna use PPS from the GPS chip, and that's 1 pulse per second. That's what PPS stands for. And basically what's happening is the GPS chip on the time card is sending a little electrical signal at the start of every second, and that's gonna sync our time down to like nanoseconds or microseconds and be very accurate. Then in the secondary clock section, we're getting our major time, which is like what time of day it is, just down to the minute or second. We're getting that from Cloudflare, time.cloudflare.com. Wow, look at that. Hey, I don't know, I feel like something's funky is going on with this one. The thing that's strange is it's like reporting to the dashboard very infrequently. Ooh, look at our offset, it's terrible. We have 5-second variance. I don't know what to do, boys. It's been a few days, but we've got the GPS antennas outside, we've got them hooked up, and we've sorted out the couple little issues we were running into. I worked it out with the Tmebeat guys, and now this all makes a lot more sense, and it isn't crashing anymore. I wanna just give you guys a little bit of background here. On the Raspberry Pi, there's like an issue with the kernel code that they use to run the Tmebeat software. It doesn't like having the GPS serial connection, which we call NMEA, as well as PPS at the same time. And they did admit to me it is kind of their own fault because they wrote the code, but they are working on a fix. But for now, we can't really do both at the same time, at least not on the newer version. This is the older version, you can see here. I'm running this on the Timecard Mini. You can see we're reading the major time from the GPS chip, and it's several hundred milliseconds out, which makes sense. And then if we look at our PPS, it's pretty accurate, but it's also a bit all over the place. For the most part, we're talking within 10 nanoseconds accuracy. But then on other times, it's 14 or 45 nanoseconds out, which is still mind-bogglingly accurate. But they were telling me on a proper setup without this bug, they're usually within 1, 2, 3 nanoseconds at all times, which is so stable. Generally, they recommended to me to just disable this NMEA data and use a public time server like time.windows.com, time.cloudflare.com as your major time source. Now you might have a problem if the internet goes out because you're losing your major time source, but the GPS chip does still have that information and the pulse per second should still stay relatively accurate. But generally if you have downtime of your main internet, you probably have bigger problems. Let's sync my laptop to it. Hey, it worked. Look at that, look how accurate the time is. If I sync to this local time server, we're like half a millisecond out. Some of that is just gonna be the clock on this Mac, probably not being the greatest thing ever, but we're also syncing over Wi-Fi. But there you go. We have a local time server getting its data from GPS and from public time servers. Our Gawk 1 Mini, our very own. Generally pretty much within 10 nanoseconds, which is kind of f***ing insane. I like this thing. It's not necessary for us at all. Don't get me wrong.
What?
For our cluster setup, as long as they're all synced to like a local time server, we have our router acting as that, it's got a pretty accurate NIC. And maybe it's not true to actual time, but as long as they all think that they're on the same time, it doesn't really matter. But this is just cool, and I like doing cool stuff like this, and I like sharing it with you. So get subscribed, hit like, and tell me what you think about accurate time. You probably don't need it either, but it is fun. And not that expensive if you buy the normal version of this and build it yourself. Bye.